Continuous. Hello, all of you are welcome to the continuous video lecture series in the chemistry, in which today we discuss about the phases and components in a phase rule. So, phase rule itself is also called the heterogeneous equilibrium, also because of the inventor is J.W. Gibbs in 1876. So phase rule also known as the Gibbs phase rule. Phase rule, what are the phases? So today we discuss about the different systems, the different equilibrium systems, and those equilibrium we have to find out the number of phases and number of component in those special uh, systems. For example, if we have the ammonia plus water, so then this will be formation of something compounds, whatever those particular, or similarly, if we have the glucose solution. So in medical aspects, the glucose solution is given. Then we have the dextrose solution, the glucose solution, and then the saline water. So in case of the saline water, sodium chloride is there. So 5% sodium chloride in the distilled water. Whatever that particular water itself is the distilled water, not the drinking water, not the potable water. Instead of that, the distilled water. So what happened when we have the water itself? So water having so many chemicals are there. So there are the number of components involved in drinking water. Whereas the pure water, that is the distilled water, however, some impurities of also present in the distilled water. Whatever that there may be the conductivity water. So those are the very costly water. So that particular chemical water plus sodium chloride. Sodium chloride itself is in the solid phase, whereas the water in case of the liquid phase. So how many number of components are present in a 5% saline water? What we have the medical science where the dripping systems, so there to avoid the dehydration in a patient, the drips are there, and that particular because of the patient have the in such conditions that the organs may be dehydrated. So for that per 5% saline water is there. So that is the system. The 5 gram sodium chloride is present in 100 ml of distilled water. Similarly, the 5% glucose. So whatever those particular, if suppose we have the blue vitriol, the copper sulfate. So copper sulfate, whatever that the normality is concerned, the equivalent weight is concerned. So therefore the different concentrations units are there. So definitely the concentration. So here one component system, whatever the degree of component is there, and then those the system controlled by the concentration. 5%, the 10%, whatever the copper sulfate solution, and by 40 and by 30. In case of the two immiscible liquid, whatever the carbon tetrachloride and the water, so there are also the condition. So whatever those two miscible liquid or whatever the miscible, whatever those may be the aqueous solution, so different solutions. We have the daily uses, that is the water. So water contains the used water, the drinking water, potable water. Number of compounds are there, so so number of components are present in a sample of drinking water because certain inorganic chemicals are present. What are those chemicals? Calcium carbonate, calcium bicarbonate. So number of chemicals in the form of their ions are present in a drinking water. So that becomes whatever that particular solution. So definitely there is the number of components available in the that particular drinking water. number of phases in that particular drinking water. So all those correlates with that. Another one, we have the physical parameters, the physical characteristics. What are those? The boiling point, the melting point, the sublimation point. So whatever those, how we can see that whatever the critical point of the pressure, critical temperature, critical pressures also. So here we can say the different solutions, different mixtures. For example, brass and bronze. Those are the two metals mixture. So whatever the compound, then the mixture, then we have the chemicals, whatever those. So here the copper and zinc, both metals in the form of they form a mixture, and those are the alloy. So here we get the number of substances, number of materials with the combination and permutations of different compounds and their involvement in the whether they are the become the homogeneous or whether they become the heterogeneous. So heterogeneous and homogeneous, what are their conditions? Heterogeneous, for example, in case of the mixture, we have the only in homogeneous the same condition, that is the same phase, but in case of the heterogeneous, two different phases are there. And what are those particular phases? So we will discuss all these in this particular presentation. So today's presentation is most important concern because of the different technologies, different technical aspects, different engineering. Those depends on the phase rule. If suppose we have the civil work, for example, construction of building, so that particular construction of building can be correlates with the iron use as well as the cement. So cement is the material, iron is the material. So what we have the binding action. So that particular binding that can be correlates with the help of that particular technology can be developed with the help of the phase rule. In case of the mechanical engineering, the strength of material, whatever all of you have well known about the steels. In case of the steels, number of various steels are there, and something there are the tool steels. So tool steels are very hard. So how we get that particular tool steel, the hardness in the compound, in the mixture of iron, in the mixture, whatever the alloy of iron. So high speed steel, very high speed steels are there. So in that particular case, the role of physics phase diagram is essential, and by which we get that particular the technology, the strength, as well as the whatever the high speed steel. So the power, whatever the power, strength of that particular strength can be obtained with the help of Gibbs phase rule, with the help of the heterogeneous system, whatever I have discussed, different phases. So role of different phases, for example, plain carbon steel, the iron, the carbon and silicon, three different elements are involved. In case of the very high speed steel, whatever the grinder, the rod, so in that particular case, the metal, tungsten or molybdenum are used because those are very hard. So therefore, the combination of two or different elements, different metals, we have to get the answers for the different technologies. So we have to see the high temperature resisting alloys. So that can be with the help of the phase diagram. So what about the phase diagram? What about the heterogeneous system? What about the Gibbs phase rule? And when which the different key points, and those are the key points are the phases. Phases, all of you well known about that. The solid, okay, then the liquid, and then the vapor. The physical characteristics of any of the substance, any of the metal, any of the element, any of the compound, and that is the boiling point. That is the melting point, most important concern of those. So, for example, in case of the nitrogen, so solid nitrogen is there, and nitrogen gas is there, and nitrogen liquid is there. So, those three different steps. So, three phases: the nitrogen in the gaseous, nitrogen, liquid nitrogen, then we have the solid. So, similarly, in case of the iron we have the liquid, iron in the form of the vapors, iron in the form of the solid. Similarly, in case of the water, the ice, the water, then the vapors. So, ice, water, and vapors. So, these three are the three different phases of the water system. So, therefore, in case of the water, we have only one chemical, and that is so. Therefore, this particular water system itself is one component. Whereas, if suppose we take the silver and lead, so there is the mixing of that, so that will having the two components. So today we have to discuss about the phases. So here, whatever the substances, whatever the materials, whatever the different phases, the solid, the liquid, and gases. Here, one more thing is there. What about the semi-solids? What about their physical state? For example, different grease and whatever the creams are used. So those are the semi-solid. For example, liquid, and in those particular case, we have the water and oil. Then they mash with each other. Then the semi-solid is present. So what about this? So that is the heterogeneous system in which water and oil, for example, palmitic oil and distilled water, both are used and then can rub with, then we get the semi-solid material. One more is the amorphous, that is in the case of the glasses. So here number of whatever the things are there, whatever the number of articles, and then their physical behavior, the physical conditions, whatever they may be in the condition of amorphous condition, that is in case of the glasses. Whatever there may be the different grease usage in different machines. So that is the what about the phases involved in those particular materials. Then we have the alloys itself are the mixtures. Whatever those mixtures may be, whatever there may be the heterogeneous, there may be the homogeneous. So those conditions, those the correct answers will be obtained. So here you can say different examples of the solid. What are those particular solids? You can say the calcium carbonate. Calcium carbonate itself is one of the example of solid material. Whatever we can say the solid material and solid compound. For example, if brass, so brass itself is the solid. That is the so in case of the brass, what we have, the brass is example of the alloy, and that is the example of a mixture, because in case of the brass, that is the pital. So pital contains two elements, two metals, and those two metals are the copper, one thing, and another thing is the zinc. So copper and zinc are present in a brass. So brass, that is the pital. So what happened in case of the pital? That is the mixture, and mixture of what? That is the mixture of copper and zinc. But what about the bronze? What about the gunmetal? So in those particular case of the gunmetal, different metals are there. For example, in case of the whatever we have the gold, and in case of the gold, there is the jewelry gold. So jewelry gold contains the gold plus copper. So that is the heterogeneous system. That is what we have the components in case of the 22 karat gold. So what happened in case of the 22 carat? That is the relationship between, that is the mixing of gold with copper. Similarly, in case of the 18 carat gold, so similarly, so those are the jewelry gold itself as the mixture. Mixture means the alloy. Alloy of what we have? Alloy of metals. So here gunmetal, for example, how we can say the gunmetal is correlates with the impacts for the whatever the bullets. So that is special. We have to see the sword. We have to see the razor. So razor blades itself is correlate whatever the main function of razor to cut down. So that particular property can be appeared with the help of the mixing of different things, and then we get the solutions, then we get the mixtures. So here homogeneous solution and whatever the heterogeneous solution, even the aqueous non-aqueous solutions, so whatever those can be correlate, and those definitely that gives a great answer for our system. So before going to that, what is the phase rule? So phase rule is an important tool used for the quantitative treatment of the systems in the equilibrium. Whatever that particular equilibrium itself is there, and we can say the equilibrium means, for example, in case of the water or alcohol. So alcohol, we have the ethyl alcohol, whatever the boiling point, we can say the isopropyl alcohol, whatever the methyl alcohol having the boiling point 64 degrees centigrade. So methyl alcohol, when we can say the room temperature itself is around 30 degrees centigrade. So what happened in case of the methyl alcohol, where the boiling point of methyl alcohol is 64 degrees centigrade. So at the 64 degrees centigrade, when we have the more heating is there to the methyl alcohol, so what happened? There is one boundary, that is the heterogeneous boundary. So heterogeneous system having either methyl alcohol maybe go towards the liquid or maybe towards the gases. So that is the heterogeneous. So what happened? And this is heterogeneous equilibrium. So for that purpose, we get the this phase rule itself is one of the important tool, and this can be used for the quantitative treatment, whatever I have earlier discussed about the brass and bronze. So in case of the bronze, whatever I have also discussed, the gold, so jewelry gold. So 18 karat gold, where 18 part is the gold and 6 part is the copper. In case of the 22 karat gold, the 22 part is the gold and 2 parts are the copper. So that is the quantitative treatment, and we get whatever the heterogeneous system will be there, and this one is called the phase rule. So this tool itself, by whatever the jewelry, the application of metals where two metals are involved, gold and copper. So there, the hardness, there, the softness, there, the other behavior, whatever the workability, so that can be quantitative treatment of the system, and then they have the equilibrium. So what we have to see the concern of the quantitative treatment of the system in the equilibrium. So therefore, the great value. If suppose we want to see the different requirements for the different technologies, whatever those particular technology sensor. So how that particular sensor can be correlate? Whatever I have discussed about the jewelry gold. So jewelry gold, that can be the hardness of the alloy, whether 22 gold carat gold is harder than the 18 out of this, which one is the harder? So therefore, because the addition of copper, the 18 karat gold, where the sixth part is the copper, 18 part is the gold. So that becomes the more harder. So therefore, in case of the jewelry articles, whatever the diamond when we have the diamond jewelry where 18 karat gold is used because that have the six part copper. So by that quantitative mixing, by that the phase diagram, we get the application of phase rule in the number of components, whatever those, and then definitely heterogeneous system will be appear. So this is the great value, the great significance of the phase rule. Whatever this is only one example. Then we have the aeroplane. So in case of the aeroplane, what we want the lightweight alloy. So lightweight because the aeroplane itself, whatever. So there is no need of heavyweight alloys, and but that particular alloy must have also the impact resistance. So therefore, phase rule where the number of components are how many, where the number of phases are how many, however, and how many number of components, one, two, three, whatever those are present in the particular substances. The lightweight material for the aeroplane, the jewelry gold for the jewelries. So that is the answer. So how we get one more thing is there. So whatever all of you have well known about the electrical engineering, where the solder wire is used. So what about the nature of solder wire must be? That must be low melting point alloy. So how we get the low melting point alloy? That is because of the quantitative treatment. So whatever, if suppose we have the bismuth, then this treat with the copper, with the other elements, whatever. For example, if tin and lead, SN and antimony both can combine, will give the one wood metal where is the very low melting point alloy. So that is can be used for the firefighting system. So therefore, the heterogeneous system, the responsibility of a heterogeneous system is from the Gibbs in 1976. So that particular industrial revolution. So definitely all the technologies are directly or indirectly correlates with the phase rule, correlates with the heterogeneous system. So that's it. The phase rule is an important tool by which we can get the different properties of different materials. So whatever that, if suppose we want the softness, we want the hardness of the material. So that can be correlated. We want to give the plasticity in that. Whatever can see, whatever the requirement. In case of the robot, we want the plasticity in that particular. So in ourself, we have the different compounds. So those are also correlates with the phase diagram. Whatever the saline water in the medical aspect, the patient is given the 5% saline water. So that is the mixture. That is the aqueous solution of salt with water. So therefore, that is also correlates with the phase rule, with the heterogeneous system. So whatever this is the simple one, it enables us to predict conditions that must be specified for a system to exhibit equilibrium. Now we have to define what are the phase rule earlier discussed in the different degree of freedoms. So two or more different phases are present equally to form a heterogeneous system. Whatever that, water, carbon tetrahydride, one thing. Whatever, if we have the water and the boiling point. So boiling point where the vapor pressure of liquid and atmospheric pressure. So both the vapor pressure of water exceeds. What about the boiling point of water? Vapor pressure of water. Whatever those particular temperature, 10 degree, 20 degree, 40 degree, the vapor pressure. We have the 90 degree, so 99 degree centigrade. So at 100 degree centigrade, so there will be the equilibrium between the liquid and vapors. So liquid having the vapor pressure, so that particular vapor pressure is exceed to the atmospheric pressure, and then will be the boiling point. So what happen at the 100 degrees centigrade, the water when we are heated, we are giving the heat, we are increase the temperature. So at 100 degrees centigrade, water will be converted into the water vapors, and that temperature is called the boiling point. However, here the involvement of pressure is also there. So that particular pressure, atmospheric pressure, and then vapor pressure generated by itself, water. So therefore, two or more different phases are present in equilibrium to form a heterogeneous system, and such systems are studied by the phase. Uh, so here all of you can get the so J. Willard W. Gibbs initiated the phase rule in 1876 on the basis of thermodynamic principle. So here the whatever one more thing is there the qualitative effect that can be seen with the help of the temperature, pressure, and the concentration. So here we can have the temperature, the pressure, and the concentration. What happens if we have the cooling mixture? For example, sodium chloride and ice. So definitely there the temperature effect, and there the melting point will be down. So that is the heterogeneous equilibrium between sodium chloride and ice. Sodium chloride is the solid, ice that is the solid. So what happened? Then they are mixing of with each other, and they form the eutectic mixture. And that eutectic mixture itself is the whatever that low temperature mixing stage, and that is the eutectic temperature at which. So here the temperature, the pressure, and concentration, all these three are the whatever that particular the temperature, and so all those are pressure and concentration are the variable, the degree of freedom. So let's we have in a heterogeneous system, in equilibrium is not affected by gravity or by electrical and magnetic forces. So the number of degree of freedom is related to the number of components and the number of phases. And this the final is the F is equal to C, where the degree of freedom is the F, and the number of component is the C, and number of phases are the P. So this can be represented here. We can give symbols. The F is number of degree of freedom. The C stand for the number of components. Then the P stand for the number of phases. Then we have the 2 plus 2, the additional variable of the temperature and pressure. So these two are the because of the variable of the temperature and pressure. So here we can say no, the only the number of component, number of phases is 2. So this is P plus F is equal to C plus 2, and this one is the called the expressively Gibbs phase rule, and this is mathematical formulation where F is equal to C minus P, and we get the plus 2. So whatever we can say here the answer. So now whatever we can say the what is the phase. It is defined as the physically distinct, homogeneous, and mechanical separable part of this. How? For example, if we have the carbon tetrachloride and water, so which one will be the phase? All of you know about the carbon tetrachloride. Carbon tetrachloride itself is one of the heaviest heavy liquid. Density is more and more as compared with the water. So CCl4 we have to take in the test tube the carbon tetrachloride, and then we add the water, distilled water. So what happened? So two immiscible liquids are there. So the phase of water is the H2O liquid, whereas in case of the carbon tetrachloride, the phase is CCl4 in the liquid. So whatever that particular homogeneous or mechanically separable, all those are the part of the system. So what happened? Physically is distinct, homogeneous, and mechanically separable. Whatever the mechanical separable in between the water and CCl4, they are not immiscible with each. Their phases are there one, and so the final answer that they have uh, the question, carbon tetrachloride and water, they are separable. A gaseous mixture constitutes a single phase since gases are gaseous. Here, the example is the air. So what happens in case of the air? The mixing of so many gases, and then major gases on nitrogen as well as the carbon dioxide. So oxygen. Oxygen and nitrogen are the major constituent and in case of the air composition. So gaseous mixture constitute a single phase, whatever this question is there, and since gases are completely miscible. So therefore, we can give the answer whatever the what type of other gases are present and how much. So that is the relationship of quantitative and qualitative aspects. So now next one, after the physics, we have to see the component, number of component. So in this particular case, it is defined as the minimum number of independent variables constituents which are required to express the composition of each phase in the system. So now we can say this is again we can component, and in a chemically reactive system the number of compound is given by C is equal to N minus E. C itself is the number of component, N is called number of chemical species, and E is the number of independent equation relating to the concentration of the species. So therefore, this one is here again we have the sulfur system. What about the sulfur? Here the number of component is one, but what happened? There is the in case of sulfur, the solid, liquid, and gases. But in solid, two forms are there: rhombic and monoclinic. So it is very difficult to give the answer for the mathematical formulation in the form of the Gibbs phase rule. So monoclinic sulfur, rhombic sulfur, liquid sulfur, and vapor sulfur. So how many number of component is one, but here the number of phases are four. So how we can say that phase rule is okay? Because here the four phases, if suppose coexist, so that is so in that particular case, whatever the P plus F is equal to C plus 2. So P plus F, the number of component and the phases. So here it is not there that there may be the one triple point, however there will be the two triple point. So that is the complicated concern about the sulfur system of the. However, in case of the water, we have already discussed the solid, liquid, and vapors, and then their curves. Curves involve the vaporization curve. Then the whatever we have the vaporization melting point curve. Melting point itself is the fusion curve. Vaporization curve itself the vapor pressure curve. So then we have one more thing is there, and that is the sublimation curve. So sublimation curve, the vaporization curve, and then the fusion curve. Fusion curve itself is the same. What about the fusion curve? So that is the melting point curve. So in case of the melting point curve, we have the curve obtain the correlation between the temperature and pressure. So that is the sublimation. So here great application of these whatever we have. So for example, we have to take the salt plus water system. So here you can say certain salts are capable of existing as a hydrate. Whatever I have discussed about the sodium and potassium with a different number of water molecule of crystallization. So here the system is of a two component system. So definitely we have the medical concern, the saline water is given. So in that particular case, the certain if salt dissolve in water, so therefore the certain salts are capable for existing as a hydrates with different number. Now the composition of each phase of hydrate is completely described in terms of the anhydrous salt and water alone and two SO4. Okay. So now next slide we have to see the different questions. So anyone can raise the hand and what you want and definitely we will give the answer. So please visit our the Suresh Gyanviar University website where I am also there. And if any of the query relates with me, all of you can search the mobile number as well as my other particulates which are also given. So now what is the number of phases and components in the following reaction? So simple reaction, iron, then we have the uh, moisture and this will converted into the FeO as well as the H2S. So here the correct answer itself is the 3.3. Here we have the two solids which are so here we have two solids and two gases. So the number of phases is two. Also the number of species is four. But we have so therefore and the number of reaction is one. So therefore the number of component is whatever we can calculate the n minus e is equal to 4 minus 1 is equal to 3. So this is the correct answer. Now one more thing is there, one another question. What is the number of phases and components in an aqueous solution of glucose? So here the correct answer, whatever that is the 1 and 2. So what we have, the here uh, the number of phases and components in an aqueous solution of glucose. So whatever the glucose is present, then we have the glucose and water itself is the component. So here we have a solid mix in a liquid and we have two components. Since the above solution is homogeneous, so we have only one phase and that is left for the human. Calculate the degree of freedom of an aqueous solution of glucose. Here the so calculate the degree of freedom of glucose. Here the correct answer is the 3. So we know that number of phases and components in the above reaction is 1A and 2 respectively since it is a one component system. So therefore F is equal to C minus P plus 2. So 2 minus 1 equal to the 2. So here the correct answer itself is 30. Now, one more question, and that is the number of phases and components in the following reaction. This one is the ammonium chloride. Ammonium chloride itself is the solid, and ammonia, that is in the form of the gases. Ammonium chloride, hydrogen chloride itself is on the gases. So here the correct answer is the 2 and 1. So what is the number of phases and um, components in the this particular reaction? So here, since we have one solid component and two gaseous component, a gaseous component contribute to one phase and solid component so contribute to this N phase, and we have the two phases is the gaseous component may be evaporated. So here we have only one. What is the number of phases and components present in the following reaction? Magnesium chloride undergoes the process of the decomposition. So the reaction magnesium oxide and carbon dioxide gas is, since we have the two solids and one gaseous component in this particular reaction and above reaction, we have three phases. What are those particular three phases of different chemicals? And three phases also, since under equilibrium the gaseous component may evaporate, so we have only two components. So what happens? That therefore this is the two component system. So the correct answer what we have, the phases are three. But the phase of magnesium carbonate, phase of magnesium oxide, and then we have the so therefore this CO2 will be evaporate. So one less will be there. Now calculate the degree of freedom for the following reaction. Here the N2O4 gas and then twice of dinitrogen tetraoxide. Here the nitrogen dioxide gas is converted. Answer is the 2. Explanation: we know that number of phases and component in the above reaction is 1 and 1. So respectively, since it is only uh, component system, so C F is equal to C minus P plus 2. So the correct answer is the 2. So this is the correct whatever the system. Now we have uh, another one, and that we can say that different components we have taken. So basically, the number of components depends on the available available mixture. So, for example, we have the suppose silver and lead. So, in case of the silver and lead, two component system. So, silver having the melting point, whatever the melting point of the lead. So we here we get the different silver and Pb, Ag plus Pb. So both having the respective melting point. But what happened? Respective melting point 961 degrees centigrade, the melting point of silver, and whereas in case of the lead, that is about 333 degrees centigrade. So 330 degrees centigrade, the melting point, and then the whatever that particular so here silver and lead form whatever that particular follow the Fichte rule, and finally we get that particular is also important relevant for the extraction of silver. So silver extraction from, because the silver and lead both are present in the earth component. So it is very, so one more thing is there here, the in case of the one component system, the number of phases are three. For example, the water, where the in case of the water, the degree of freedom that can be correlates with whatever the percentage, the composition, one thing, and we have the temperature relationship, then the pressure. So, for example, if anyone can give the question answer, what is the boiling point of water? So anyone can easily give that boiling point of water is 100 degrees centigrade. So whatever that particular temperature, so their temperature, the number of component is one in case of the water, and whatever then we can say. So here the component, the phases, then the degree of freedom, all these three are involved in a system. So in our life, whatever we have the various equilibrium in between those, and so therefore this one is also called as the whatever the degree of the phase rule, the Gibbs phase rule. We have already discussed about the Gibbs phase rule, and that Gibbs has given the 1976, and J. Willard Gibson initiated phase rule in 1876 on the basis of thermodynamic principle. So here, whatever the thermodynamic aspects, that those can be correlate with the whatever thermodynamic principles are given. So here, uh, um, so lastly, if anyone have any difficulty, because whatever the homogeneous, whatever the heterogeneous, so a mixture, whatever may be the heterogeneous. So in case of the heterogeneous, we have another. So this one is called the phase rule. Why this phase rule? Because of the phases. And what are those particular phases? We have already discussed about one of the video lecture series in which one component application was there and one component system where water was involved. So the that particular water having the sublimation curve, the vapor pressure curve, the melting point, the fusion curve. So these three um, different parts of the whatever those are the degree of freedom. Temperature, one thing, the pressure, another thing, and so definitely temperature, pressure, and one is the concentration. How much amount of that particular substance is present in the glucose water. So here the 5 gram of glucose is dissolved in 100 ml of water. So whatever this particular, so here we have the different ones, and so we can conclude here, and all of you are welcome to ask me the questions. Questions those may be the related with the present topic, or maybe other whatever all of you have the thing, the mobile number, so you can contact me through the mobile, or whatever contact through the mail. So my email ID also given in the Suresh Canvia University website, and my, so you can call me at any time. Whatever that I give the response. So even you can also write the mail to me, or whatever the any of the question relevant, and then we can solve the problems. So this one basically the phase rule is to solve the problem. This is not to make the complication. So the answer itself is to give the certain technology. So that one will be because of this. So okay, all of you have to welcome to get because of the knowledge sharing, knowledge receiving is also one of the important part of a human being. So you have to see